Good morning and welcome to class. This morning, our agenda for today is to watch a video from 8 to 8:20 a.m. And then after that, we'll have the Zoom call from 8:20 to 9 a.m. So that's our agenda for today. And today, we want to continue with more problems on indefinite integrals, how to find indefinite integrals. And specifically, we want to look at these examples, indefinite integrals with fractional exponents. And these are three examples that we want to look at today. So please track the screen for today's lesson. So the first question we want to look at is to evaluate the integral below. Number one, integral of e to the power x plus x raised to the power 5 over 2 plus x raised to the power 1 over 4. How do you find the integral of this? Based on a previous lesson, we said that if you're adding different functions, you can apply the sum rule. And the sum rule says that you can split up each function and take the integral of each of them. So let's do that now. So you have integral of e to the x dx plus the integral of x to the power 5 over 2 dx plus integral of x to the power 1 over 4 dx. So that is the sum rule applied. Split the terms up. Now let's take the integral of each of the terms. The integral of e to the x, as we know, is always e to the x. So let's write that down, e to the x. Then plus, now I have to find the integral of x to the power 5 over 4. How do I do that? Take 30 seconds to think about that, and we'll continue. Great. So in this case, I have to apply the anti-power rule. So the anti-power rule says that I have to add 1 to the exponent. So let's do that. So x raised to the power 5 over 2 plus 1. And then I divide by the sum that I get here. So 5 over 2 plus 1. Whatever the sum is, I divide by that. Plus, if I can do the same thing here, I can apply the anti-power rule because x raised to an exponent. So add 1 to the exponent, which is 1 over 4 plus 1, and divide by the sum, which is 1 over 4 plus 1. And then plus the constant c. Right, so let's simplify what we have. This will be e to the power x plus x raised to the power 5 over 2 plus 1. How do I do that? Now let's look at that on the side here. So if you have 5 over 2 plus 1, what is this equal to? Since I'm adding two fractions, I have to find the LCD. So it's 5 over 2 plus this will be what? 2 over 2, because it's like 1 over 1, right? So it's 2 over 2. Then I can add the numerators. So I have 7 over 2. Okay, so that would be the exponent for this. So this would be 7 over 2, all right? And then I divide this by this sum, which is 7 over 2. Plus, do the same thing here, add 1 over 4 to 1, so it's 1 over 4 plus 1, which is the same as 1 over 4, LCD is 4, but this is 1 over 1. So you have plus 4 over 1, sorry, 4 over 4, and that gives us 5 over 4. So this would be x to the power 5 over 4. Divide this by the sum, which is 5 over 4, plus the constant c. Right? We are not yet done. We have to simplify it further. So I want you to think about dividing two fractions. Okay. If I'm dividing two fractions, let's say if I have 1 divided by 7 over 2, what do I do? 1 divided by 7 over 2. What happens? You keep the first fraction, the numerator, which is 1 over 1, times reciprocal of the denominator, which is 2 over 7. So that gives us 2 over 7. So in other words, you take the reciprocal of this fraction, the denominator, and multiply by the fraction in the numerator. So let's do that. So this becomes 2 over 7 times x to the power 7 over 2, plus the same thing here, 1 divided by 5 over 4. So it will be 1 times reciprocal of 5 over 4, which becomes 4 over 5. So it's 4 over 5 times x to the power 5 over 4, plus the constant c. Right? So this will be our answer in the simplified form. Great. So take 30 seconds to look at what I've just done. So one, I want you to think about the steps that I used to solve this, to simplify this problem. Take 30 seconds to write down the steps. What are the key steps that I used to find the integral of this expression? Great. Let's pause here. So what are the key steps that I used to find the integral of this problem? One, if I have a fractional exponent, to find the integral, I have to add 1 to the exponent and divide by the sum that I get. So that's anti-power rule. So the anti-power rule. Okay, so if I have x to the power n, the integral of that is x raised to the power n plus 1 over n plus 1, and then plus the constant. Don't forget that. Okay, great. Let's go to the second example. So in the second example, we have integral of 5 raised to the power, 5 times x raised to the power 3 over 4 plus x raised to the power 1 over 3 plus sine x plus sine x. So let's apply the sum rule since we are adding three different functions, right? So let's split this up. So we have integral of, I can put the 5 in front as a constant. So constant multiplies is 5 x to the power 3 over 4 dx, okay, the constant multiplier rule that we know, plus integral of x to the power 1 over 3 dx, plus integral of sine x dx, the sum rule. So let's find the integrals now. So we can find the integral of this, x to the power 3 over 4. So that it becomes 5 times x raised to the power 3 over 4 plus 1, power rule, anti-power rule, right? And divide by the sum, which is 3 over 4 plus 1, plus integral of x to the power 1/3, which will be x to the power 1 over 3 plus 1 over 1 over 3 plus 1, plus what is the the antiderivative of sine. The antiderivative of sine is negative cos x, and we add a c to it, right? So let's simplify what we have. So to simplify this, we have to add the exponents. So remember, this is the same as 4 over 4, all right? 4 over 4, because the LCD is 4 over 4. So add a 4 to the 3, so we have x to the power 7 over 4, right? And divide by 7 over 4. Plus, this is 3, so this will be 3 over 3, right? It's 1 over 1, LCD is 3, so it's 3 over 3. So add the 3 to the 1, so that'll be x to the power 4 over 3. And divide by the sum 4 over 3 minus cos of x. Or plus minus becomes minus cos of x plus c. So you end up with, if we simplify this, you're dividing 5 by 7 over 4, so reciprocal of that will be 4 over 7 times the 5x to the power 7 over 4 plus 1 divided by 4 over 3, so reciprocal of the denominator. So we have 3 over 4 x to the power 4 over 3 minus cos of x plus the constant c. So that if you simplify this further, what we get, you have 20 over 7 x raised to the power 7 over 4 plus 3 over 4 x to the power 4 over 3 minus cos of x, and then plus the constant c, right? So this is the answer in the simplified form. Right, so for now, don't worry yourself changing this to the radical form. Let's keep it like this for now. Okay, good. All right. So look at this, take 30 seconds to look at what I just did. And then write down your key steps in your own words, the steps that I used to arrive at this particular answer. Okay. All right. Great. Let's move on to the last example. Now, in the last example, I have integral of 5 over x minus 3 x raised to the power 2 over 5 plus 6 over x to the power 2 over 3, right? So if you look at this, you think it's very complex, but it's not complex if you take some few seconds to think through what we've just done. Okay. So again, we can apply the sum and difference rule here. So let's split up each term. So I have integral of 5 over x dx minus integral of 3x raised to the power 2 over 5 dx plus integral of 6 over x raised to the power 2 over 3 dx. Okay, first step, split up using the sum and difference rule. Right, how do we simplify this portion here, 5 over x? Based on our knowledge, I can factor out the 5 and put in front of the integral. So it's a constant multiplier. And we know that we can easily take the integral of 1 over x. So this is just a 5 times 1 over x dx. 3 is a constant multiplier, put that in front. So we factor that out of the integral, becomes 3 times integral of x to the power 2 over 5 dx. Plus, now let's pause a second and think about this part here. What can we do from a lesson, a previous lesson? What do we know? We know that if I have a fractional exponent in the denominator, or I have a fraction, I can change this to an exponent. You say change to the exponential form. So to change this to exponential form means that I have to bring this base to the numerator, and once I do that, it means that I have to put a negative sign in front of the exponent. So that's the negative exponent rule. So let's do that. So I have integral of 6 x raised to the power negative 2 over 3 dx. Okay. So now we can easily take the integral of what we have. So let's do that now. So what's the integral of 1 over x? It is natural log of the absolute value of x. So it's 5 times the natural log of the absolute value of x minus 3 times. Now here we have to apply the power rule because x raised to an exponent. So it's 2 to the 5 plus 1, and then we divide by the sum that we get. Plus, do the same thing here. 6 is a constant multiplier, so we can write that down, 6 in front. The integral of x to the power negative 2 over 3, add 1 to that, and divide by the sum, negative 2 over 3 plus 1, and add a constant. So let's simplify further. It's 5 natural log of x, absolute value of x, minus 3x to the power. What would this be? 2 over 5 plus 1. So it's 1 over 1. LCD is 5. So this will be 5 over 5. So we have 2 plus 5, which will be 7 over LCD of 5, divided by the sum, which is 7 over 5. Plus, this is 6 x raised to the power negative 2 over 3 plus 1. So you have negative 2 over 3 plus 1 is the same as negative 2 over 3 LCD. So it's 3 over 3. So negative 2 plus 3, negative 2 plus 3, that gives us 1 over 3 over the sum, which is 1 over 3 plus c. So let's finalize this. We have 5 natural log of x, absolute value of x, minus 3 x to the power 7 over 5 over 7 over 5, plus this will be, we have, let me just rewrite this down. Okay, should have done that here. So we'll have 3 times 6x to the power 1/3 over 1, reciprocal of this, plus c. Okay, I should have simplified this, but let's do that now. So we have 5 natural log of x. So this becomes 7 and 5 over 7, reciprocal of this. So it's 5 over 7 divided by 5 divided by 7 times 3x 7 over 5 plus 3 times 6x 1/3 plus c. So let's finalize our answer. So our final answer will be 5 natural log of x minus 15 over 7 x to the power 7 over 5 plus this will be 18 x to the power 1/3 plus c. So this will be a simplified answer. Right. Great. So take 30 seconds one more time to look at the solution. And again, write down in your own words the steps that I used to approach this question. If you're done, write down any questions that you may have, and I'll see you on the Zoom call at 8:20. See you soon. Bye.